It's Monday, and today we're going to talk about graphing using vertex form, which is the easiest way to graph. You guys are going to love it. We're also going to talk about changing from standard form into vertex form by completing the square. These notes are on Canvas, so whatever we don't get to, you can just look on Canvas. I will try my best to get through as much as I can in the 15 minutes allotted, but then after that, just whatever we miss, go on to Canvas, check it out, and then your homework is on Delta Math. All right, so vertex form. It's very similar to vertex form for absolute value functions, where it has the inside is left and right, the outside's up and down, and then any stretching and shrinking is that a value. So your vertex is going to be at hk, so however left and right, however up and down. And then a parabola actually has an odd pattern. I like to call it the 1, 3, 5 pattern instead of the odd pattern, but it doesn't really matter, whatever you want to call it. So given the parent function for a quadratic, our vertex is always going to be at 0, 0, and it actually has this odd pattern, which is really cool. From the vertex, to get to the next point, you go up 1 over 1. To get from this point, and again, they're symmetric, to get up to this point, you go up 1 over 1. To get from here to here, you're going to go up 1, 2, 3 over 1, and up 1, 2, 3 over 1. So up 3 over 1. And then you're going to go up 1, 2, 3, 4, 5 over 1, and then up 5 over 1. So hence the 1, 3, 5 pattern. Obviously 7, 9, 11, it would keep going. So an odd pattern, but I like to call it the 1, 3, 5 pattern. All right, so let's just go ahead and do it several times. All right, your vertex is always going to be the opposite of the inside, same as the outside. So that's going to be -3, -4. So I'm just going to go ahead and put a dot at -3, -4, 1, 2, 3, 4. That's actually where my AOS is going to be automatically. We know, remember back to, I don't know, however many days ago it's been. Here's your vertex. Your AOS is going to be that X value. So -3. So I'm going to take and I'm going to draw my axis of symmetry at -3. And all my other points are going to be mirror images on either side of that AOS. So to do my 1, 3, 5 pattern, it is always 1, 3, 5, but the A value out front is going to stretch or shrink this function. I don't have any number out front, so I have an understood 1. So my 1, 3, 5 pattern is still going to stay 1, 3, 5 pattern. So it's going to go up 1, and we're always going to go over 1. You're never going to change that. So you're always going to go up 1, over 1, up 3, over 1, etc. I left space to write the word up, just so that you know it's going up or down. If it's positive, it goes up. If it's negative, it goes down. And then 5 times 1 is up 5 over 1. So while graphing this, literally take your point and then go up 1 to the right and up 1 to the left. From this point, go up 1, 2, 3, 1 to the right, and go over here to the left and go up 1, 2, 3, and 1 to the left. Then over here, go up 1, 2, 3, 4, 5, 1 to the right, and then also over here up 5 and 1 to the left. And that is it. You're done. You should have symmetry on either side, so I'm just going to go ahead and do my best to make a smooth parabolic curve, and I'm done. Max min is always going to be the same number here, so it is going to be a minimum, and it's going to be -4. I'm not going to write these transformations out in their full way, but you could. So it did move left 3 units, it moved down 4 units, no reflection because no negative out front, and no stretching or shrinking. All right, our next example, find your vertex. Again, opposite of the inside, same as the outside. So +3, +5. So I'm going to go put a dot at 1, 2, 3, 1, 2, 3, 4, 5. Then my AOS automatically is always X equals whatever that X value is for your vertex, so X equals 3. So I'm just going to draw an up and down line at X equals 3. And then I'm going to do my 1, 3, 5 pattern, but it's always 1, 3, 5 starting out, whatever your A value is out front, which in this case is a -1. So I'm going to multiply my 1, 3, 5 pattern by a -1 all the way down the line. So instead of going up, it is going to go down 1 over 1, down 3 over 1, and down 5 over 1, sorry. Okay, so from this point, I'm going to go down 1, and then 1 to the left, and 1 to the right. Okay, from this point, go down 1, 2, 3, go right and go left. And then from this point, go down 1, 2, 3, 4, 5, go right and go left. And if you have that AOS, it makes it easy to see that symmetry. Do your very best to have a smooth parabolic curve. And then if you look at it, it has a maximum value. So I know it's a max and it's always going to match my vertex Y value. Transformations, it went right 3, it went up 5, and it does have a reflection over the x-axis. I'm just going to shorthand that there. That's terrible. Oh, ignore that. Okay. And that's it for that guy. I did go ahead and skip number 3 just because we don't have enough time. So go back and look at that on the notes. But here, vertex is opposite of the inside, same as the outside. So it's going to be a +1, -5. AOS is always going to match that value. So I'm going to go over to 1 and then -1, 2, 3, 4, 5 and put a dot. And I didn't write on this one what you have, but always on your paper write a 1, 3, 5 pattern and just multiply by whatever that A value is. So in this case, 1/2. And if it's positive, it's going to go up. So I'm going to go up 1/2 and then over 1. I'm not going to write the over 1 because it's always over 1. Okay, 3 times 1/2 is up 1.5 over 1, and 5 times 1/2 is up 2.5 over 1. So from this dot, which I'm going to go ahead and draw my AOS, I'm going to go up 1/2, and I'm always going to go left and right 1. You're never going to change that number ever. From these, I'm going to go up 1.5 and over 1, and from here I'm going to go up 2.5 over 1. I could even do the next number. 7 times 1/2 is up 3.5. So then I could go up 1/2, 1, 2, 3 over 1, and same thing on that side. And I probably could even go up a little further than that, but that's definitely plenty. You just need on Delta Math 5 points, and if you were graphing on a test for me, I would also want to see 5 points. But the main point is knowing it's a 1, 3, 5 pattern always. Whatever that A value is, you multiply 1, 3, and 5 by that, and you always go up and over 1 or down and over 1, whatever that value is. All right, my minimum is going to match my vertex, -5. Transformations, it went right 1, down 5, and it had a vertical shrink by a factor of 1/2. And you can just see those on the notes, just trying to save time. All right, so let's move on to the back side. All right, so now we're going to convert from standard form to vertex form so that you can actually graph this guy. We do know how to graph in standard form. You do that -b over 2a, find that x value of the vertex, plug it back in, find the y value, make a table of values, plot all your points. I promise you, vertex form is the easiest way to graph. Once you get your vertex, you do that 1, 3, 5 pattern. It's very easy. So if you're given a standard form equation, convert it to vertex form, and then do the 1, 3, 5 pattern. I've taught this 2 different ways. I'm going to show you the way I think that works better this year for my students, but if you want to see an old method, another method, you can check out the 8-6 notes from last semester. I changed it for you guys. Okay, so what you're going to do is we're going to complete the square. So, but I have a y value here. Normally I have a 0. You're still going to behave the exact same way, but just leave y alone. So normally we would get x squared and x by itself, so move this 8 over. So I'm just going to say y plus 8. And on the right side, I'm going to have that x squared plus 12x. We'd normally just have a number over here, not that y, but it doesn't matter. I'm still, because I have x squared isolated, I don't have a number with it, and I have x by itself there, I can go ahead and add the same thing to both sides. And remember, you cut that b value in half. So I'm going to go over onto this side and take my x term and cut it in half. Half of 12 is 6. I'm going to add 6 squared to both sides. And it may have been a hot minute since you guys have completed the square, so I will do as many examples as time allows. Okay, so I've added 6 squared to both sides. Okay, on the left side, this is going to be 36 plus 8, which is 44. On the right side, don't forget, when you complete that perfect square trinomial, you just take your first term and that last term, and whatever sign obviously you took with you, that's the sign you're going to use, and you just square it. And bonus here, you don't need to do anything else, square rooting or anything. You literally get y by itself. So move this 44 over by minusing it. And you're done. I now have my vertex, which would be at -6, -44. My A value is a 1, so I'd have that 1, 3, 5 pattern. I could easily graph this guy and be done. If you did -b over 2a, you would have gotten a -6. Plug it back in, you would have gotten a -44. You could have gotten the same answer another way. but this was very, very simple. All right, so let me show you what happens if we do not have that x squared already isolated. Same exact process. I still want to get x squared and x alone, so I'm going to move this 3 across the equal sign. So I'm going to have y minus 3 equals 2x squared minus 8x. But in order to complete the square, I have to have just an x squared. I cannot have that 2. So I'm going to divide every single term by 2, including that y. Okay, that's going to leave me y over 2 minus 3 halves equals, oh, I should have left some space. I'm going to go ahead and put plus space, equals, this goes away, you just get x squared minus 4x, and then I'm going to go ahead and add some space. So whenever you get x squared and x alone, that's when you're going to add the space. All right, what am I adding to both sides? Well, I'm adding half of my b value. Half of negative 4 is negative 2, and I'm going to square it. Sorry, I'm running out of space here. And negative 2, and I'm going to square it. All right, the right side, because it's a little easier for me just right now, the right side is going to be x minus 2 squared. The left side is going to be 5 halves, so y halves minus 5 halves. That comes from 4 minus 3 halves, or 8 halves minus 3 halves is negative 5 halves. Oh, is not negative 5 halves, positive 5 halves. 8 minus 3 is positive 5. Okay, and then I want to get y by itself, so I'm going to move this 5 halves over. So I'm going to get y halves equals parentheses x minus 2 squared minus 5 halves. And I want to get y by itself, so last step is to multiply by 2. So multiply everything by 2, you're going to get y equals. Multiply by 2 here, you're going to get 2x minus 2 squared. And then when you multiply by 2 here, you get a 5. Vertex is positive 2, negative 5. It has an a value of 2, so my 1, 3, 5 pattern would be multiplied by a 2. All right, to save time, I went ahead and already did the first step. I took my problem, I copied it down. I want to get x squared and x alone, so I added 4 to that side. I have to get x squared by itself, so I cannot have that 3. So I'm going to divide every single term by 3. I'm just trying to save time. We'll read the directions at the very end if we have time. Okay, I'm going to go ahead and add some space. And then 3x squared divided by 3 is just straight up x squared. That's going to give me 2x plus some space. To complete the square, I'm going to add half that middle value, so that's a negative 1 squared added to both sides. This is going to give me y thirds plus 7 thirds. And the right side is going to be copy the first, copy the last, squared. Okay, I'm going to add that 7 thirds over, so I'm going to get y thirds. I'm not, sorry, not added over, subtracted over, I apologize, because I'm trying to get it off that side, so minus 7 thirds. And I cannot have this y thirds, so I need to multiply by 3, so I'll just do that right here. I'm going to get y equals, multiplying by 3, you just get that value on the outside there, x minus 1 squared, and then that's going to be a minus 7. Okay, so to answer the question, it said identify the direction of the opening. Well, that comes from the a value. If it's a positive, it's going to open upward, so it's going to open upward like this guy. Okay, find the vertex. Well, the vertex is now at positive 1, negative 7. Negative 7. Identify the max or the min. Well, if that's opening upward, I know that it's going to have a minimum value, and that's going to be at negative 7. And the number of x-intercepts. That comes from, if I graph this and I have it at over 1 and at negative 7, and it's opening upward, I know that it's going to cross the x-axis 2 separate times, so it's going to have 2 different answers for x-intercepts. To save time on this last one, I went ahead and already did the first few steps, so I moved that 1 over the equal sign, and then I had to divide by a negative sign because I can't have a negative x squared, so I divided every single term by negative, and because I've already isolated x squared and x, I went ahead and added space to both sides. Just trying to save time because we got less than a minute. All right, half of negative 4 is negative 2 squared. Half of negative 4 is negative 2 squared. This left side is going to be negative y, and then 4 minus 1 is a positive 3. The right side is always going to be the first term and the last term. I'm going to move that 3 over, so negative y equals x minus 2 squared minus 3. And then divide by a negative or multiply by a negative 1. I'm going to get negative x minus 2 squared plus 3. All right, vertex will be at 2, 3, and then you're going to do the 1, 3, 5 pattern, but you're going to multiply by a negative 1. So it's going to be going down 1, down 3, and down 5.